Hello. Hello and welcome to this video. This is the 35th set of problems on theoretic equations, quadratic equations and polynomials. We have solved till question 340. So we will solve from 341 to 350. Before we start solving, I'll show you how to download this PDF. So you can go to my website www.astocker.org and click the second link, and this file will open, and you can click this save button on your browser to download this file on your laptop or mobile or computer. Copyright notice needs to be updated to 26. Okay. Note that you cannot buy this book in the market because I have not published it. The reason for not publishing is the fact that if I publish it, then the publisher will not allow me to keep an online copy for you guys. That is why I have not updated it. I have not published it, and it will not be published. This date is 2026-01, 10th January. So it was last updated on 10th January. Whenever it is updated, the date will change. Okay, so you can come again after a few days and check whether it has changed or not, and download the latest version. So as I go along, if I find typing mistakes, I update that, and then this date will change. So with that out of the way, let's get started. So as always, I'll say that when I'm stating the problem, you should pause the video, and only if you cannot solve the problem, you should look at the solution. So question 341 says that if x plus y is constant, prove that xy is maximum when x is equal to y. So we let x plus y is equal to k, then z is equal to xy is equal to x into k minus x. So the equation becomes x square minus kx plus z is equal to 0. Now x is real, so discriminant would be greater than equal to 0, that is k square minus 4z greater than equal to 0, that is z less than equal to k square by 4. So the maximum value of z is k square by 4. We put k square by 4 in the equation, and we get x is equal to k by 2. Now x is equal to k by 2, then y is also k by 2, and thus xy is maximum when x is equal to y. The other way to solve this problem would be using arithmetic mean and geometric mean inequality. So x plus y by 2 will be greater than equal to square root of xy. So x plus y whole square will be greater than equal to 4xy when you square it. So you will get that x minus y whole square greater than equal to 0. So the minimum value will be when x is equal to, the maximum value will be when x is equal to y. So from arithmetic mean and geometric mean also you can solve this. Now we move on to question 342. If x be real, find the maximum value of 3 minus 6x minus 8x square and the corresponding value of x. So we have y is equal to 3 minus 6x minus 8x square. So 8x square plus 6x plus y minus 3. X will be real. So discriminant would be greater than equal to 0. So we compute the discriminant. It is 36 minus 32 y minus 3. So y is less than equal to 33 by 8. So maximum value of y would be 33 by 8. We substitute this value in the original equation. We get 64x square plus 48x plus 9 is equal to 0. So from that we get x is equal to minus 3 by 8. Next question is, prove that mod of 12x by 4x square plus 9 less than equal to 1 for all real values of x, or the equality being satisfied only if mod x is equal to 3 by 2. So we let, like previous problems, y is equal to 12x by 4x square plus 9. So you know the drill, we get 4yx square minus 12x plus 9y is equal to 0. Now again, discriminant would be greater than equal to 0. So 144 minus 144 y square greater than equal to 0, y square less than equal to 1. And that means minus 1 less than equal to y less than equal to 1. So mod y would be less than equal to 1. So mod of 12x by 4x square plus 9 less than equal to 1. Now if we assume the equality, then we will have 4 mod x square minus 12 mod x plus 9 equal to 0. That is 2 mod x minus 3 whole square is equal to 0. So mod x is equal to 3 by 2. Question 344 says that prove that if the equation x square plus 9y square minus 4x plus 3 is equal to 0 is satisfied for real values of x and y, x must lie between 1 and 3 and y must lie between minus 1 by 3 and 1 by 3. So since x is real for this given equation, the discriminant would be greater than or equal to 0. So discriminant would be minus 4 whole square minus 4 into 9y square plus 3 greater than or equal to 0, which gives us 9y square minus 1 less than or equal to 0. So y square less than or equal to 1 by 9, that is y will lie between minus 1 by 3 and 1 by 3. The given equation can also be written as 9y square plus x square minus 4x plus 3. Since y is real, d would be greater than or equal to 0. So again we compute the discriminant, it would be minus 36 into x square minus 4x plus 3 greater than or equal to 0. That is x square minus 4x plus 3 less than or equal to 0. Since coefficient of x square is positive, it must lie between its root for the above expression to be negative. Therefore, x must lie between 1 and 3 because the roots of this corresponding equation are 1 and 3. Question 345 says that find the value of a for which x square minus ax plus 1 minus 2a square greater than 0 for all real value of x. So in this case also, since the discriminant of the corresponding equation has to be negative, because it has to be always positive for all values of x, so discriminant must be negative. So compute the discriminant, it is a square minus 4 into 1 minus 2a square less than or equal to 0, that is 9a square less than or equal to 4. So a must lie between minus 2 by 3 and 2 by 3. Question 346 says that determine a such that x square minus 11x plus a and x square minus 14x plus 2a may have a common factor. So we let alpha to be the common factor which will satisfy both the equation. We get alpha square minus 11 alpha plus a is equal to 0 and alpha square minus 14 alpha plus 2a is equal to 0. We do cross multiplication, we get alpha square by minus 22a plus 14x is equal to alpha by a minus 2a is equal to 1 by minus 14 plus 11. We get alpha square by minus 8a is equal to alpha by minus a is equal to minus 1 by 3. So from first two terms we have alpha is equal to 8, and from the last two we have alpha is equal to a by 3. So a by 3 will be equal to 8, so a is equal to 24. Question 347 says that find the condition that the expressions ax square plus bxy plus cy square and a1x square plus b1xy plus c1y square may have factors y minus mx and my minus x respectively. So first we let y is equal to mx is a factor of both the quadratic expressions, and so they will be 0 when y will be mx. So y is equal to mx, we substitute, we get x square plus bx into mx plus cm square x square, that is cm square plus bm plus a is equal to 0. Similarly, a1m square plus b1m plus c1 is equal to 0 since my minus x is a factor of a1x square plus b1xy plus c1y square. Now we solve both the equations in m by cross multiplication. We get m square by bc1 minus ab1 is equal to m by aa1 minus cc1 is equal to 1 by cb1 minus ba1. So from first two we get m is equal to bc1 minus ab1 by aa1 minus cc1, and from the last two we get m is equal to a1 minus cc1 divided by cb1 minus ba1. Now we equate both the values of m, we get bc1 minus ab1 into cb1 minus ba1 is equal to a1 minus cc1 whole square. Question 348 says that find the values of m for which the expression 2x square plus mxy plus 3y square minus 5y minus 2 can be resolved into two linear factors. So from theory, if you study the theory, it is given, we know that x square plus 2hxy plus by square plus 2gx plus 2fy plus c can be resolved into linear factors if and only if abc plus 2fgh minus f square minus bg square minus ch square is equal to 0 and h square minus ab greater than 0. So for the given expression, we have a is equal to 2, h is equal to m by 2, b is equal to 3, g is equal to 0, f is equal to minus 5 by 2, c is equal to minus 2. So h square minus ab is m square by 4 minus 6 is equal to 0, so m square greater than 24. And applying the condition, that is this condition abc plus 2fg8 and so on, we get minus 12 minus 25 by 2 plus m square by 2 is equal to 0, so m square is equal to 49, that is m is equal to plus minus 7. Question 349 says that if the expression x square plus by square plus cz square plus 2ayz plus 2bzx plus 2cxy can be resolved into rational factors, prove that a cube plus b cube plus c cube is equal to 3abc. So using the same technique for which we used for the previous, we have got this equation as z square with took common and we get a by x plus z whole square plus by z whole square plus c plus 2a into y by z plus 2b into x by z plus 2c xy by z square. We write this as z square into a into capital X square plus b into capital Y square plus c into 2a capital Y plus 2b into capital X plus 2c into capital XY, where capital X is equal to x by z, capital Y is equal to y by z. Now this will resolve into linear factors if ABC plus 2ABC minus a square minus bb square minus cc square, that is equal to 0. There is a missing 0 here. So question 349, I'll update it. So from this we get the required condition a cube plus b cube plus c cube is equal to 3abc. Now we come to the last question of this set. Find the linear factors of 2x square minus y square minus x plus xy plus 2y minus 1. So the corresponding equation is 2x square minus y square minus x plus xy plus 2y minus 1 is equal to 0. So x is equal to 1 minus y plus minus square root of 1 minus y whole square plus 8 into y square minus 2y plus 1 by 4, which implies that x is equal to 1 minus y or minus 1 minus y by 2. Therefore, the required linear factors are x plus y minus 1 and 2x minus y plus 1. So with this, we come to the end of 35th set of problems on the quadratic equations. Do not worry about downloading the PDF because I will give the link in the description. You can click the link and it will be downloaded. So I hope that you are enjoying the series on algebra. Okay, a lot of videos have been uploaded. You might want to watch the entire playlist. So share it with your friends and do not forget to like and comment if you have anything to say. If you have any questions, any doubts, let me know in the comments. And you might also want to press the bell icon after subscription so that you can get notified about the upcoming videos. So I'll see you in the next video with 36 set of problems. Thanks a lot for watching. Enjoy.